This is a modified version of the previous tool, but it's designed to capture the human understanding of what people who are fighting look like. So if you test this, these stick images update, and I've categorized 300 of these to say whether they were fighting or not. So I learned the model on 300 different things, but these are all generated fresh. So it's guessing. So it thinks they're dancing. It thinks they're fighting. That looks pretty reasonable. It thinks they're dancing. Yeah. It thinks they're fighting. Good. I think the punch to the head must be an indicator. I don't see that as fighting, but it could be a slap. This is fighting. Yes. Yeah. That's dancing. I would say that's dancing. You got that wrong. That one is posturing for a fight. Anyway, I've been training it for only about 10,000 iterations, and that's the best I've got so far. But if I initialize it again, so it hasn't got a clue, and then I run, say, 5,000 iterations, or we could do 10,000 iterations, you would see, hopefully, a nice chart of the learning curve, and you would see it guessing. So at the moment, it hasn't got a clue. So the fact that it's saying dancing is really just luck. But every 25 iterations on the training set of these stick figures, it's going to have a stab. That's fighting, clearly, but it thinks it's dancing. But it has no idea, because it's only learning the data set, which is 300 images that I've labeled. So I'm going to maybe pause here, maybe get one more update. Well, I'll pause shortly, and we can see how the learning curve develops and see what the hit rate is. Now, it's incredibly subjective, obviously. Dancing, it's looking good, but this is the cost curve's kind of dropping through, and you'll see how far it has to improve. And I shall come back after the next one to report on this and show you the state of the learning curve and its ability to understand the fundamental human concepts of aggression as encoded in these stick figures. Well, unfortunately, I hadn't extended my print range for the learning curve, but one would assume it would start flattening out. And the test cases seem to be better. It thinks that's dancing. It thinks that that is fighting. Yes, possibly. It thinks that that's fight, so that was definitely fighting. Dancing, maybe. Looks like a reasonably relaxed posture. Yeah, fighting. I think that looks more like dancing. But yes, fighting, hand to the throat. Dancing. Yeah, so look, well, it's great. So let me explain a little bit more about where that data came from very quickly. It was generated on this sheet. So this is randomly generating stick figures. If I press F9, then it makes a stick figure. Now, if I can figure out what that stick figure is, and if I think they're fighting and I try to store it, then that's now stored in this data set of, I think, 300 potentials I've got. So I think that is difficult. I think that might be dancing, actually. So I'm going to call that dancing. Dancing, definitely. I think fighting, body posture, the fist. So I'll store that one's fighting. So basically, I've done 300 of these, and yeah, I could happily do a lot more. And I think that would perhaps catch what I think I see in these images that makes me overanalyze stick figures and think they're either fighting or dancing. In this case, I'm really just categorizing fighting and assuming all else is non-aggressive. And that data set that we're generating here is going to go, or at 306, so we just made 6 more. It is going to get put into the model. This is all the model is. These are all the cases that I trained. It's 300 long, but I can make that take in all that is made and hopefully catch the essence of what fighting is within in the neural network. And that's it. That's where it's got to so far. I will report back if anybody's interested in this. Please comment. Yeah.